Okay, so for number 9, we have a 250 milliliter flask, and we're given that the reaction, and for the reaction, we're given that K is equal to 0.045. And we have 1 gram of the solid, and we know that the solid doesn't matter for equilibrium as long as it doesn't run out, and we're told that there's excess. And in this, it's injected with 0.21 moles of Cl2. So of the Cl2, we have 0.21 moles, and so to get molarity, we do 0.21 moles over 0.25 liters, and that gives us 0.84 molarity. So we're starting out with 0.84 molarity of the chlorine, and none of these two. So we're going to choose X to be something with a 1 coefficient, so we're going to add X for N2. We're going to add 2x for the BCl3, and we're going to subtract 3x for the Cl2. And we're going to subtract 2x of molarity, but because this is a solid, that's not really going to matter. So we're going to have 0.84 minus 3x, that's the chlorine. We're going to have 2x for the BCl3, and we're going to have x for the nitrogen. In our equilibrium expression, our K is going to equal the concentration of the BCl3 squared times the concentration of the N2 divided by the concentration of the Cl2 cubed. And so 0.045 is going to equal 2x squared times x divided by 0.84 minus 3x cubed. And if I simplify this fraction, it becomes 4x cubed over 0.84 minus 3x cubed. And so to solve this, we're going to cube root both sides. So we're going to cube root both sides of this fraction. And so the cube root of 0.045, so I'm going to do 0.045 raised to the 1/3, or you can use the math feature and do cube root. And we get 0.356 is equal to the cube root of 4, so 4 raised to the 1/3, and we get 1.59x over 0.84 minus 3x. And then we're going to multiply both sides by 0.84 minus 3x, 0.84 minus 3x. And we'll end up on the right-hand side, we have 1.59x, and on the left-hand side, 0.84 times 0.356 is equal to 0.299 minus 3 times 0.356, 1.068x. Okay, so if I add the 1.068 to both sides, 1.068x to both sides, I end up with the last step here that we have plus 2.658x is equal to 0.299. And so divide by 2.658 and we get that x, 0.299 divided by 2.658. We get x is equal to 0.11 molarity. So that's what x is, so your nitrogen would be 0.11. And so we're looking for what is the concentration of the BCl3, so that's going to be 2x. And so the concentration of the BCl3 is going to be 0.22 molarity at equilibrium. Okay, and then the question now is, what if, part 2 says, would the reaction achieve equilibrium if the flask initially contained 1 gram of BN solid? Support your answer with calculations. So we were told initially we had 1 gram of excess. And now the question says, would we get to equilibrium if we only had 1 gram of this, not 1 gram extra? So we were told initially we had whatever we needed plus 1 gram of extra. So in order to figure out if we would get to equilibrium, we need to figure out if stoichiometrically, if x is 0.11 molarity, right, and we're in a 250 milliliter flask, so 0.11 times 0.25, that means I need 0.0275 moles of the N2. And since the BN solid is a 2-to-1 ratio, that means I'm going to need, for the BN solid, we would need 0.275 times 2 moles, which is 0.055 moles. That's what we would have needed in order to get to equilibrium without running out of that. And so the question is 1 gram, is 0.055 moles, is 1 gram enough? So we can get the molar mass of the boron nitride, and we can find out that 0.055 moles, that's what we need. That's more than 1 gram. So if you started out with 1 gram of the boron nitride, you wouldn't have enough to reach equilibrium. And that's how you do that type of problem.